Hi everyone, thanks for joining today's session. So we're going to talking about Apache Spark on the Kubernetes, best practice and performance on the cloud. So this is today's agenda. So simply two parts. The first part, we're talking about the scenarios and our practice for the Spark service in the cloud. The second part, we're talking about the Spark on the Kubernetes with some architecture overview, best practice details, and some performance hints. Before we go into start, a quick introduction on ourselves. So my name is Junping. I come from the Tencent Cloud, principal engineer and director of cloud data warehousing. I'm Apache Hadoop committer PMC and ASF member. Previously, I was working at Hortonworks, young development team, and previous that is a VMware for working on some Hadoop on virtualization stuff. So this is my colleague, Jimmy. He's a senior software engineer at Tencent Cloud, working on some Hadoop, Spark stuff. He's a long-term contributors to this open source project as well. And previously, he's performance engineer in the Intel for the performance evaluation on the Spark. So a quick survey here. So how many of you know hear about Tencent? Can you raise your hand? Okay, most of them. Thank you. Another one. How many of you know that Tencent actually offering the public cloud services? How many of you? Yeah, very few. You broke my heart. Just joking. Yeah, so actually, Tencent is one of the largest internet company in China, is offering social network services like WeChat, QQ, and also the video and music casting services. But since very latest years, like 2013-14, they start trying to offering the public cloud services. But it's growing very fast, and now it's the top two largest cloud vendors in local market. One thing worth to mention is we are the first Apache Platinum sponsors from China. So that is means we also do a lot of open source contributions on Hadoop, Spark, Flink, HBase, etc. So let's back to the topic. Stay with the topic. So that is case study and scenarios for the Spark in the cloud. So we actually have a Sparkling, it's Spark-based data warehouse services in the Tencent. So basically, whatever your data it's a relational database or it's in the object store, it's called COS in Tencent Cloud. So or you have some data in the EMR, Elastic MapReduce service, or the computing as stream computing services. This data all flow into the Sparkling and get consumed by the downstream data application like BI or machine learning. So here's a quick architecture overview for Sparkling. So basically, they have a data warehouse manager to manage all this life cycle of these resources and the services. And it's talking with Tencent cloud infrastructure that is VM-based infrastructure. So, and also the key parts is, of course, is the SQL engines that is Spark-based and the Spark-SQL-based. But we do some optimization in the execution, in the physical execution level and the column storage. And it also has a data thing to connected to the external data sources such as Elasticsearch and some NoSQL engines like HBase. So other than that, we're also providing some very handy tools like a notebook service or workflow management service, and the data science or data engineers can using to writing their own data application and put it on the in a DAG data pipeline. We're also offering data map and data catalog, so you can easy to manage your data through the Sparkling. So that is VM-based architecture, but why we need the Kubernetes? Why we need Dockerized all the Spark? The thing is, at least we find the two requirements. The first thing is serverless. So many user or customer, they actually want something, they don't care about where the class state is. They don't want to maintain a dedicated cluster for their job. They just want to launch the query and get results or run their job somewhere. They don't care, right? So the serverless is one of the key motivations. But they need a better isolation, like container side, like container. It's a way to do the better isolation. The other one behind this modification is on-premise. So a lot of people actually they still have concerns to move into the public cloud, right? So they want something deployed on their own data center with some restrictions. So in this case, we need to offer something that can be deployed on the bare metal infrastructures, because previously the public cloud things environment quite different, and you have to offer something like DevOps capabilities or tools in a cost-effective way. So that's two important motivations. So what do we do is actually moving the Sparkling from the VM-based towards the Kubernetes-based. A lot of change work need to do here. So here is just a short list. Like in the API changes, you have to change from the VM-based API, like the create a VM or suspend a VM, to the container, more lightweight and more hop-on-hop-off style. And also you need to change the some networking components. Like previously, you may have different load balancer or DNS. So now Kubernetes have some own standardized networking components. And also the least, but not the last but not the least, the CMM image, and quite different with the Docker image, and different size and different management lifecycle. So this is all the things you need to handle. So I think in the years of 2019, you don't have to talking about what is Kubernetes, because everyone knows what is Kubernetes, I think. But the thing is, from the Spark or big data perspective, what is Kubernetes? Actually, it just means it's another open source cluster manager, just like what Yarn or Mesos previously does. So, but the thing is, the Kubernetes is quite popular now, and it's a large community and behind of that. So just 4 or 5 years, it's already have more than 2,000 contributors and have 75 commits across these years. So briefly, architecture of the Kubernetes, I think the key concept here is the pods. So that is a wrapper or a unit of the scheduling and isolation unit. So basically, you can have different pods across different machines. So this daemons or these containers within the same pod, they can communicate each other, but the pods between them is kind of isolated way. The many advantages of the Kubernetes. The first one is portability. So your application, your service can be seamlessly migrate from the one cluster to the other one without too much changes. And also the isolation is better for performance and security. So that is very helpful for deliver serverless kind of the service. And also they provide a lot of handy tools for out-of-box management, such as namespace, audience, authentications, logs, monitoring kind of thing. And also it can help for the deployment heterogeneously deployment, such as nodes with GPU or without GPU or FPGA size. It's all handled very well. And also the community is large and is large adoption in the industry. That means any solutions built on top of that Kubernetes that can be easily to benefit the whole industry and have a more the end user adoption. So there's it's basically 2 ways to launch your Spark on the Kubernetes workflow. So the first one is just you launch the Spark job in the way of Spark Summit. So basically, you just through the client, you launch your Spark, and it goes through the API servers going through the scheduling, and it's get deployed on the Kubernetes cluster. And you have a driver, you have Spark driver and Spark executors get launched, and your cluster is set up and your job is running. The other one is the Kubernetes Spark operator, just announced recently by Google in the Kubernetes community. So that way, so you have a long-running operator there. They have different daemons, like you have the controllers to control all the Spark application objects, life circles, and it's talking with the submission runner and to do the real Spark launcher, and also it has the pod monitor to monitor all the pod's status and get back to the controller for better decision, and also has a mutating animation webhook that is provides some callback functionality, allows you do something customization for your Spark drivers or Spark executed on the fly, such as volume or some config map. Okay, so here's a quick summarizing on the Spark Kubernetes status. I think most of this point is according to the latest one. So in both Spark community and Kubernetes community, they did tons of work, such as make Spark cluster or client-side mode works perfect on the Kubernetes, and also it support the local or shared storage volume mounts. And the multiple languages like R or Python get supported recently. And also the operator providing Spark control command line is more convenient to launch your Spark job there. So my colleague Jimmy will demo a little bit on that. And also they have providing a native cron tab support that's for the time lane schedule. So previously Kubernetes is more like supported long-running services, but now it's a batch mode of jobs in a timely scheduled way. It gets supported. There's also some significant ongoing work like dynamic execution allocation is working on that. So it's more with the dynamic execution model, so you will have more efficient on your Spark job in consuming your resources. There's some other going work like Spark operator H8, because current Spark operator, this daemons, if it's done, you have to start your manually to make sure the whole thing is working. And also some like a GPU scheduling is added there for Spark, and the work is still going on. Okay, so with all this work, so the sparkling on the Kubernetes has been evolving to the new architecture. So all the service daemons, in packaging into the pod, can be accessed, public access through the ingress, and all the Spark executors, the drivers, and packaging as a pod as well, and they can cross all these nodes. Okay, so my part is done. So the next part, Jimmy will show some performance and some demos and practice. Thanks.
Okay. So I'm going to show you. I'm going to start with two very simple examples to show you how to run the Spark application on the Kubernetes cluster. And let me change the console. I will start to So to run the Spark application on the Kubernetes cluster, firstly you will need to know what is your cluster info, because you will pass the URL, the IP, and the port to the Spark submit. So this is the cluster we have, and then you can check the ports inside the cluster. Sorry. Okay. So I know there should be some morph is low, right?
Yeah, I think the demo is pretty straightforward. Just show you the operating model and also the client model. I think that's something easy. We can skip.
Okay.
So we can just go through.
Oh,
yeah.
You can see that, right? In the let me.
You can see that.
This. Okay. Okay. I know that there should be some more sort, so I also some I'm open the screen, but still not working. Let me try it again.
What? No, he wanted to show the command line, but didn't casting into the screen.
Wasn't coming to the screen.
Yeah.
Is he doing a extended desktop?
No, it's just the
Anyway.
command line.
Let me start something like this. Yeah, there's you can get the Kubernetes cluster info, and you can check the port inside the Kubernetes cluster. And this video is a lot a bit. That you can see that the Spark Pi was run successfully, and we can use the logs command to check the logs inside the driver. Yeah, that's it. It's very easy. It was to note that you may need to build your own Spark images, Docker images to include some dependency jars of your Spark application, and you can also specify the jars in the remote locations like HDFS, HTTP server, and etc. And another way to run is to through the kube control or Spark control command. And first of all, you will need to install the Spark operator on your Kubernetes cluster. And thanks to the Heron, this is true. Just like Linux, the Linux, we have apt or the yum install script, and that is what Heron done. And you can install the Spark operator using just one command like I just listed here, and then you can declare you will need to declare YAML to specify how you will run the Spark application, including resource quota, the Docker image you will use, and the exector resource quota, etc. And then you can you can run the application through these two commands. I also have a demo, but I can show you. Yeah. So firstly, you can see that there's a Spark operator, and this is the Spark Pi. This is the Spark Pi YAML I just wrote. We have a declared driver resource quota, and we have the exector resource quota. We have the images. We have the application. Yeah, and then you can run the application. Yeah, that's it. Yeah, and then you can use the describe command to show the status inside fault pods. And we can see that the driver was created and the exector was created and running, and just wait for a while. Yeah, we can see that the application already done successfully, and we have a Pi. Yeah, this is to Hello World application we just showed. And now I'll go show you some benchmarks we run on about the Spark on Kubernetes. And we run some benchmark on the Tencent cloud, and with this environment, we allocate a cluster which have one master node and 6 workers, and the master node has 8 CPU and 8 CPU core and 64 GB memory, and we have one disk for the root file system, which is 50 GB, and one SSD disk for the data disk. And for the slaves, we have the 32 CPU cores, and we have 128 GB memory, and we also have data disk 4 HDD data disk. Yeah. That's a hardware set. And for the Spark on Yarn side, we also allocate same hardware cluster. And for the software setup, we most of them are same, except the resource scheduler, and both of them use the HDFS from the Hadoop 2.7.3 release, and we use the Spark latest release 2.4.1, and the operating system we use is CentOS 7.2. And so here's the first benchmark we run is the Terasort. As you guys may all know, that the Terasort is a well-known sort benchmark for the big data. It is from the sort benchmark, and it generates the data from on the HDFS and read run to the read run input file and sort run, and finally write data. And yeah, the configuration I use is we use is 5 executors, and each of the executor we use 10 GB memory and 2 CPU cores. And you can see in the right chart that Spark on Kubernetes run a bit slower than on the Spark on Yarn. And the second round we run is the larger data size with 500 GB. And Spark on Kubernetes always fails, but Spark on Yarn, we can finish the job within 35 minutes. So what's wrong with the Spark on Kubernetes? And we check the logs and describe use the log command and describe a report, and we found that the pod always get evicted, and from the driver log we can see that the task get lost. Most of them get lost due to the pod get evicted. So and from the log capture here, we can see that the pod get evicted due to the disk pressure on the node file system. So why this happens? And we check the Spark current code base, and we found that the Spark on Kubernetes use the empty directory volume for the Spark local storage, and the empty directory volume from the Kubernetes, it is ephemeral storage, which share the same life cycle of the pod, and it will use the node file system. And as we know, that the Kubernetes workspace is on the root file system, so we just allocate 50 gigabytes on the for the root file system, so it will always fail due to the disk pressure. So on this below capture, we can see that the empty directory was on the was mounted from the Kubernetes workspace. So how do we fix this? And there are two solutions. The first one is from the Spark master branch. We checked the code and found that the empty directory can be changed to mount to the RAM back the volume, and with the configuration list here, and you can set this configuration to true, and the empty directory will mount it as a RAM FS, and it uses the exactor memory. So basically, you need to enlarge the exactor memory to make this work. And the second solution is you may need to enlarge the data capacity of the Kubernetes workspace. And on the cloud environment, I think the second solution is very easy, as we know that you can buy some elastic data disk and change and you can modify the Kubernetes configure and restart to use it. Yeah, we tried both, and it seems. And here's the result. The third pillar is the result of if we use the RAM-based MTDR volume, and it ran a bit faster than the Spark on Yarn as we expected. And another benchmark we ran and we failed to run is the 500 gigabyte Terasort, and now it can run successfully without any pod eviction. And the second suite of the benchmark we run is the Spark-sql-perf from the Databricks, and it contains the TPC-DS and the TPC-H workloads, which represent the real scenario use case. And we run application based on the Spark-sql library, Spark-sql-perf library, and we also pick up 10 queries, which are either shuffle bounded or IO bounded. And then this is the command we use to run the Spark-sql, the TPC-DS workload. And here's the preliminary benchmark result of the TPC-DS workload for the data scale of the 1 terabyte. And the configuration we use is we use the 24 exactor instance, which each of them has a 24 gigabyte memory and 6 CPU core. And you can see in the right chart that the Spark on Kubernetes runs much slower on the Spark compared to the Spark on Yarn. And so why this still slow? And we checked the status from the monitor on the cloud, and we found some clues. We found that when we're running in the Kubernetes mode, there's only one disk have the heavy I/O overhead, and when we're running from the Yarn cluster, all the data disk have the I/O overhead. And it shows, as we know that Spark will spill files to the disk when the memory is tight, right? So in the Yarn mode, there's much more bandwidth than the Kubernetes. So that's why it will run a bit slower. So how can we fix this? There's also one possible workaround we have tried, that is use the RAM-based empty directory. And though we can enlarge the exact memory to the very large value, but it still cannot successfully run the TPC-DS workload. When we checked inside the pod, we found that there's many, the pod get evicted due to the out of memory because the TPC-DS suite have the much large data scale. Yeah. So why can we use the the Spark on Yarn way to mount the Spark exact local storage to multiple disks to to fully utilize the disk bandwidth? So I think the answer is yes. We have we have checked the we checked the code base of the Spark Kubernetes pod build logic, and we found that there's something we can improve, and that is we can before we build the local directory feature, we can check that if there's any variance mount already existing in the pod, and then we can use it as the Spark local storage. And that is the these are the configurations when we apply the patch from this 274999 ticket. And after we apply these configurations, we evaluate, we run the benchmark, and as you can see from left chart, that the performance improved a lot compared to the previous preliminary one, and even compared to the Spark on Yarn. I think some of them performs better than Spark on Yarn. Some of the perform bad, but I think it appears to the Spark on Yarn, but we may still have something to improve. But there's improved. That's the fix. I think we fixed the Spark local storage issues. And that's all for our practice on the tuning of some performance tuning on the cloud. So in summary, we can say that Spark on Kubernetes Spark on Kubernetes get more and more popular due to the serverless and the cloud native trend, but it still have some issues, problems, like such as local storage issues. We have hit, and we are working with the community for better solution and better practice. And that, I think that's all for.
All right, we've got a few minutes for a couple questions. For those who have questions, it would be helpful to line up right over here, and we can take a few questions.
Hey, Junping. Just a quick question. Based on your Yarn background, right? Could you share some insights in terms of how capacity, workload, scheduling kind of management has worked out?
Sorry, I cannot hear quite clear.
So from an ad hoc workload perspective, how has your capacity management or scheduling kind of concept sort of worked between Yarn versus Kubernetes for Spark?
I think so far.
For those who are exiting, please try to be quiet until you're out of the room. Got some Q&A. Thank you.
I think question is comparing with job scheduling, capacity management. What is different for Kubernetes and the Yarn? I think so far comparing with Yarn in the big data or Spark supportive. I mean, high-level scheduling thing is not as perfect as Yarn, because Yarn we know we have a different fair queue or fair scheduler or capacity scheduler. You can have different queues, and you can scheduling these tasks or capacities on demand or ad hocly. So far, this kind of Kubernetes scheduling is more like a static, and it's you first deploy on some of the nodes or the pods, and then how to managing this or how to divided this into the different queues is still, I think, in the progress. So in this sense, I would say in high level, I mean, in the job scheduling part I think Kubernetes so far is still catching up compared with the Yarn. So another way, considerable way, is maybe deploy Yarn on top of Kubernetes, kind of you're managing some kind of job scheduling things, and you can support Spark or other things. I think this is something recently worth discussion in the Yarn community. Maybe one of the workaround here. Yep.
So does Kubernetes consider data locality when they deploy the pods? And have you found that matters in your benchmark?
Yes, I think data locality things is a quite of a lot of people are asking about this, right? Because in Hadoop, so you can the resource manager, you can talking with the name node asking where the block it is and try to scheduling based on that. So far, I think Kubernetes doesn't have this, but today we're talking about the cloud scenario. So in cloud scenario, a lot of data locality actually cannot be guaranteed, like it's just a blob storage or kind of thing. So I mean, in recent years, this data locality things is I can see the less and less important. According to the public cloud trends or some optimization, like they have the cache in different layers. I think this problem is it's not that much. But as you said, if Kubernetes can support awareness of the data locality or the locality of data, that would be perfect. So there's an ongoing working actually in the Hadoop. Ozone, that's the HDFS v2 things. I think that part of work is try to make the Kubernetes kind of aware of the Ozone, the data replica, not a replica. It's something the data container there, kind of. Yeah, thanks.
First, thank you very much for the great talk. Lots of great insights.
Thanks.
Indeed. I have questions in two areas. One is about the shuffle service. Did you try, what shuffle service did you use? Did you try different shuffle service? Second area is the dynamic allocation. When do you expect that to be available in Kubernetes?
Yeah. So what is?
Oh, the first question is about shuffle service. I think we are using the traditional shuffle service of Spark.
Yeah, we use the we use the static shuffle service.
The second one is dynamic allocation. I think it's claimed in the Spark community. It says 3.0 they will have a GA for Spark on the Kubernetes. That means in 3.0 of Spark it should be support this. But I think this part of work is still going on. So before we ship. So we never guarantee that. Thanks. Yeah.
So I noticed on the very last slide with numbers that after you improve Kubernetes performance, that significantly, in many cases, Spark on Kubernetes was faster than on Yarn. But on two of them, I think it was Q64 and 80, Spark on Yarn was still the faster one. I was wondering if you know why that discrepancy exists.
I mean, typically, Yarn should be faster than Kubernetes, but in our slides, while we show, I think there's some different. If you look at the slides, I think if we're using RAM-based disk, it will be faster than the Yarn. But the last one, some query is faster, some query is slower. So I would say, actually, if you have the same deployment, the Yarn and Kubernetes is a little bit peers. It's not to mean Kubernetes is faster. I think so, right?
Yeah, it's, on the right chart is compare the Spark on Kubernetes.
Yeah, the first. Yeah.
64 is a very complex multi-sig, right?
Mm-hmm.
Yeah, so that's why it's so.
Yeah.
Yeah, so in general, it should be peers, I mean, for Kubernetes and Yarn. So at the first you can see the Kubernetes is faster because we are using the RAM-backed file system. Yep. Yeah.
I think we have time for one more question, and I'm sure you guys can stick around if,
Yeah.
if there's a few more questions. We can
Sure.
stick around, but one more official question.
Hey guys, thank you. Can I ask you questions about your journey to serverless Spark? Is this already in production? And if so, I mean, how long did it take you from your initial POC trials to get to production?
Production.
Thank
Okay,
you.
so the first thing is Sparkling is a production cloud data warehousing offering, but not the Kubernetes one. So this is still in at POC stage. We're moving towards the serverless part, but because the Spark on the Kubernetes happen to be GA, so we have to waiting for that. So my estimation could be the end of this year or early next year we'll put on the on the production and for inside or outside the customer to using this serverless version of queries on Spark-sql. Yeah.
And how long have you been doing this?
You mean how long to developing this?
To get
Yeah, we're keeping developing, but some of the features, some of the hitting ad hoc problems we are hitting, and some optimization we are keep going on. So I think maybe from the beginning we already take about 3 months or more. Yeah, and I think it's maybe another 6 months, something like that. Yeah. Thanks. Yeah.
Thank you.
Yeah. Thank you.